There is a lot of water on Mars and there once was a lot of surface flowing water. You don't see it because most of it is mixed with the soil which we call regolith on Mars, so the Martian soil can be anywhere from as little as 1% in some very dry desert like areas to as much as 60% water. So, one strategy for getting water when you're on Mars is to break up the regolith, which would take something like a jackhammer because it's very cold, it's very frozen. If you can imagine making a frozen brick or a chunk of ice that's mostly soil and maybe half water and half soil, that's what you would be dealing with. So, you need to break this up. Put it in an oven. As it heats up it turns to steam. You run it through a distillation tube and you have pure drinking water that comes out the other end. There is a much easier way to get water on Mars. In this country we have developed industrial dehumidifiers, and they're very simple machines that simply blow the air in a room or a building across a mineral called zeolite. Zeolite is very common on Earth, it's very common on Mars. And zeolite is kind of like a sponge. It absorbs water like crazy. Takes the humidity right out of the air. Then you squeeze it and out comes the water.
In today's lecture, I'm going to talk about changes in air pollution since the middle of the last century and what has created these changes. So, by the 1950s, air pollution was very visible, with frequent thick black fogs known as smogs in many large cities around the world. The main source of this pollution was from factories, and it caused severe health problems. For example, a particularly severe smog in London in 1952 caused over 4,000 deaths. Obviously, something had to be done, and in 1956 a Clean Air Act was introduced in Britain. This addressed the pollution from factories, and the smog soon disappeared. However, as you know, these days air pollution is still a big issue. The main difference between now and the 1950s is that you can't see it, it's invisible. Also, the main source of pollution now is from cars and lorries, and although these don't produce visible signs, this air pollution is still a significant risk to health. And one of the key factors in the rise of this type of pollution is that we have all become much more vehicle dependent. There are far more cars and lorries, trains and planes than in the 1950s, and this is now the main source of air pollution around the world.
Thirdly, life from non-living matter. And this illustration often used is the one of the monkeys at the typewriter. Okay, so we have a monkey sitting at a typewriter, and the claim here is basically if you leave chance and time long enough, you will get life. Don't worry about it. Yes, it's strange. Yes, it's wonderful. But leave enough matter, 600 million years on Earth, and you will have life. So the monkey's sitting at the typewriter, and the chances are eventually he produces the complete works of Shakespeare, so what's the problem? So there's no problem, there isn't an issue, right? You just leave him long enough, you'll be fine. And at 1 keystroke a second, the monkey might well eventually get to the complete works of Shakespeare, but he doesn't manage to do it in 600 million years. So what I decided to do to run the numbers is instead of saying type the complete works of Shakespeare, I just ran the numbers for how long would it take a monkey typing at 1 keystroke a second to type to be or not to be, that is the question. Right? On average, how long is it going to take my monkey friend at 1 keystroke a second? I don't know how long you think that would be. Maybe you could have a guess. Would it be less or more than 600 million years, which is the period life on Earth is supposed to have emerged within? And when I ran the numbers, to be or not to be, that is the question, takes 12.6 trillion years to type just that phrase. And a DNA string, which you have to have for the life we have now, doesn't emerge it's not like a sentence's worth of information. A DNA string has got as much information as the Encyclopedia Britannica. Right? So if we're saying that emerged, something of that complexity emerged by chance, undirected, within 600 million years, again, it's mathematically possible, but it's so incredibly unlikely that it would have, that it tilts me in favor of the Christian story in which God creating life is simply a question of saying, let there be, and there was.
We'll do a demonstration to illustrate the difference between the thermodynamic control and the kinetic control of the product of a reaction. We'll put a 0.05 molar solution of mercury 2 chloride in a beaker. We will add some 0.1 molar potassium iodide. We notice the formation of a reddish-orange solid. This solid is the product of thermodynamic control. It is the more stable product. We will now mix dilute solutions of mercury 2 chloride and potassium iodide. We see the formation of a yellow solid. This is the product of kinetic control. It is not the more stable product. Over time, the yellow product will undergo the reverse reaction and then eventually form the more stable product. The solution turns orange.
This is the first ocean deployment of two new high-precision instruments designed to monitor the Earth's signals from the seafloor. This housing contains the tiltmeter and nanobottom pressure recorder and the associated electronics and cabling used for power and communications. The instruments were deployed on the seafloor by a remotely operated vehicle as part of the Mars Seafloor Observatory testbed located at a depth of 3,000 feet in Monterey Bay. In this first test deployment in the ocean, they have already detected the ground motion from several large earthquakes, as far from the Mars site as Chile and the Mariana Trench. In the future, the instruments will be part of a global network of cabled seafloor observatories. Because of their precision, these two new instruments are already detecting signals which could never be measured before.
Joseph Lister was an English surgeon who was the first man to realise the importance of aseptic techniques during surgical procedures. Lister was born in Essex, England, and after obtaining a Bachelor of Arts degree from University College London, he qualified as a doctor in 1852. Lister became assistant surgeon at Edinburgh Royal Infirmary and was later made surgeon at the Glasgow Royal Infirmary in Scotland. The accepted belief at the time was that contact of an open wound with moisture in the air caused infection, so surgical wounds were covered after operating with non-sterile cloths, which increased the risk of infection. Lister refused to accept this theory, and after reading the works of Louis Pasteur, he tried to prevent bacterial infection of surgical wounds by applying pure carbolic acid to surgical dressings, as well as cleaning wounds with the acid during and after surgery. Lister studied the effects of his treatment for 2 years and then published his findings. This led to the adoption of doctors wearing white gowns, which were used to show dirt, and using surgical gauze and carbolic acid to clean wounds after surgery. Lister successfully treated Queen Victoria using his new methods, and he was appointed chairman of clinical surgery at King's College Hospital, London, where he continued his research into antiseptics and clean surgery until he retired in 1893, and died in Kent, England, aged 85.
Dr. Grievous, how important is vitamin D with regards to health?
Very importantly. Vitamin D, which, by the way, is not really a vitamin,
That's right.
It's a hormone, steroid-like hormone, is responsible for upregulating, the last count I got, over 200 genes in the body that regulate normal body metabolism. In fact, now we've found vitamin D receptors in almost every organ system and every cell. So for optimum health, we have to have sufficient quantities of vitamin D.
Now, how common is vitamin D deficiency?
Vitamin D deficiency is now considered to be pandemic worldwide, not just in certain countries, but in almost all countries. And it's interesting that even in those tropical countries where you would think there's plenty of sunlight, that most people are so clothing themselves that they are limiting how much sun they actually do get. And so even in some countries like the Saudi Arabia and these, at least half of the population still are vitamin D deficient.
is a question that few are willing to ask, which is why do we need to control immigration anyway? And my answer to that would be we don't. My answer would be we should open up our borders and we should fight for the free movement for all, no ifs, no point systems, no buts, no categories. And we should do this because the freedom of movement should be enjoyed universally. I would argue for the freedom of movement for all from a humanist point of view, where the desire to seek a better life, to move around the world, is the germ of the history-making process. Without it, we would all stand still. And I think, actually, this is a shining example of what makes us human. And I think we should look forward to more people, because more people are more pair of hands, more creators, more thinkers, more brain cells. More people means more allies, more mates, more love affairs.